Hello and welcome to the 4.2 videos. This is a section that's all about the vertex, and we already looked at a formula for the vertex of a parabola in section 3.3, and this video is just to review that one to make sure you know it, because we're going to be using that one here too. So for this equation, y equals ax squared plus bx plus c, an yield parabola, the x-coordinate of the vertex is given by this formula. So let's do an example of that. Here is this equation, y equals negative 2x squared plus x plus 1. Let's find the vertex of that. So to start, we're just going to say we're going to use the formula for xv is negative b over 2a. And we can just plug in our values of b and a into that. So the negative b will be negative 1, because it's like there's a 1 times x here. And it's that over 2 times a, which means 2 times negative 2. So you can then simplify this to get negative 1 over negative 4, which is just the same as 1 over 4. So that's the x-coordinate of the vertex. Now to get the y-coordinate of the vertex, we're just going to plug in this x-coordinate that we have and see what is the corresponding y-coordinate in the equation. So here is the equation that gives you y-coordinates of points when you plug in the x-coordinates. So we're going to do 1/4 squared. That gives you 1 squared divided by 4 squared. So we can write that part as negative 2 times 1 over 16. And then the 1/4 is just 1 fourth, and then the 1 is just 1. So that's that. Negative 2 divided by 16, you can reduce that to write that as negative 1/8 over 16. And then these other fractions, let's make them be divided by 8 as well, so we can combine them. So the 1 over 4 would be 2/8. The 1 is 8/8. So now we can combine these all and get 10 minus 1 is 9/8. So the vertex itself, we know, is a point with this x-coordinate and this y-coordinate. And if you want, you can write that as a decimal too. So anyways, that's the vertex. And what I also want to explore is how do we know if this is a minimum or a maximum y value? So if you have a parabola that opens upwards, a parabola that opens upwards is going to look kind of like this one, with the vertex is going to be the lowest point. And the lowest point means that the y-coordinate of the vertex there is going to be the lowest y value. All of these other points have y-coordinates that are higher up somewhere. So, so in this case, that would be the minimum y-coordinate. And I also want to point out that this kind of thing happens when a is greater than 0. When in the formula y equals ax squared plus bx plus c, when a is greater than 0, you get an upward opening parabola. And you'll also have a situation like this when your a value is less than 0. So you have a negative number times x squared. And in that case, when it's opening downward, the vertex is the highest point. And being the highest point, that means it has the maximum y-coordinate. So in our case, our a value is negative 2. So that means that our situation looks kind of like this, and the vertex is going to be the maximum y-coordinate. So you could also check that if you just graph this on your calculator. So I'm going to graph it by going to y equals, deleting what's there, negative 2 times x squared plus x plus 1. And we can check out this graph. And yeah, it looks kind of like that situation. It looks like the vertex is about 0.25, and the y-coordinate of the vertex is a little bit over 1, so that agrees with what we had before. So that sounds good. Next, here's a couple of questions for you to do. This first reading question I think is interesting. It might help you understand parabolas a little bit better, but no worries if you get it wrong. You might want to check your answers before class if you're not sure about these. And I wanted to point out that when we say this d is the discriminant, just a reminder that that is just a fancy word for the b squared minus 4ac part of the quadratic formula. And so there's that. And then exercise 1 here is for you to do. This is really similar to the example we just did, so it's a little practice for that. So good luck with these. And but before you get started and before I end the video, I want to point out that the next item for you guys to do is a read item. I'm going to have you read this maximum or minimum values along with this example and do a reading question and an exercise. That is a lot of work, but I just want to make sure that when you're reading, don't rush through it. Don't look at the reading as just like, how is this going to get you to the exercise? Reading a math book and really understanding it is a thing that needs to happen slowly. So just like my videos usually last, 5 or 10 minutes long, I would have spent 5 or 10 minutes on a video here, and that means you really, if you're working on stuff on your own, you really need to spend 10 or 15 minutes to do the problems at the end and everything. So the same is true here. You should be spending 10 or 15 minutes just to read the example, try to make sure you're understanding it as you go, do the reading question, and do exercise 2. If you're doing it in less than 10 minutes, you're probably going too fast, and it might just go in one ear and out the other if you're not careful. So just wanted to make sure that you knew that, and I will stop telling you what to do right now and let you do it.